Good day, everyone. We are Green Guardians, a team of two, Danroy and Manasseh from Nairobi, Kenya. We are here to introduce EnviroKen, an innovative solution that leverages machine learning to revolutionize waste management. Our topic of interest is sustainable manufacturing, developing AI solutions that reduce waste, improve energy efficiency, and promote circular economy practices in industrial settings. Our solution encompasses two machine learning models. One, an image classification model trained on the powerful VGG16 architecture to accurately classify waste images into their appropriate classes. Currently, the model identifies waste in 6 classes, namely plastics, glass, metal, paper, organic waste, and finally e-waste. The second model is a text generation model that builds upon the output of the first model and gives personalized recommendations depending on the identified waste type. By doing this, our solution aims to equip users with knowledge on how to handle waste, reusing and reducing waste, and hopefully contribute to UN's mission of a circular economy, moving away from a culture of make, use, and dispose to a culture of make, use, reuse, recycle. Our solution also aims to contribute to the global mission of Sustainable Development Goals, with a particular focus on SDG number 9 on innovation and infrastructure, SDG number 11 on sustainable cities, and SDG number 12 on responsible consumption. With EnviroKen, waste management becomes a breeze. We like to think of it as picture perfect recycling, where you snap, classify your waste type, and finally get information on how to handle your waste. My teammate Danroy will now take us through the demonstration.
My name is Danroy Mwangi. I'm part of Green Guardians, and our project is EnviroKen. So I'm going to talk about the technical side of everything and demonstrate things. So first of all, as I explained, we're going to be running this. So you can upload any images that are downloaded, images that you have taken on your own phone. So the example that I am uploading right now is an image that I took today. So the model is going to take a bit of time to turn on, so 20 seconds. As it does that, I can explain what happens. So you upload the image, then it goes through the image classifier, which classifies it based off the categories that Manasseh had mentioned. So organic, paper, plastic, e-waste, metal, and glass. And you can see it has predicted correctly. So this is organic since it's vegetable waste. So we can click the recommendations. So the recommendations are generated by the text generation model, which is a T5 small model that has been fine-tuned on a subset of data. And it gives you the proper recommendation for you, depending on your type of waste. So repurpose coffee grounds as soil amendment in gardens. So that's reduce. We can try recycling. So we see what it's going to generate. Okay, it's taking a bit of time. Might be an error. Let me just reload it. So sometimes the model might crash, which is expected, since it's actually very heavy to run. So recycling, use recycled composted material for landscaping and landscaping projects. Then you can click the video recommendations that are there. So make a kitchen waste compost easily at home. So this is relevant to the type of the waste. And you can also upload different images for different kinds of waste. So we can move on to the next image, which is e-waste. Then we upload that. And now this is the image, and it's supposed to predict as e-waste. And we have it here as e-waste. So as you can see, you also get a reward for using the platform and also for inquiring about different ways to manage waste. So let's see what it's going to generate. So educate on the environmental impact of e-waste and how to minimize it. That's reducing. Then there are a few links over here. As that loads, you can click the next one and how to reduce recycled e-waste rather, educate on impacts of e-waste and recycling, sort of similar to the initial one. Now this is reuse of outdated electronics for repurpose and upgrading. Yeah, so that's very useful. You can click the second last link to see what it generates. Now, this is one of the recommended videos that was given. Okay, it's actually the same video. It tends to do that sometimes since the recommender is the video recommender is a bit rudimentary at this stage. Yeah, so this is another example of a video.
Young people around the world are.
So it combines a lot of elements, so you can try and classify and also recommend for different kind. We can go with this. It's a different type of image for food waste. So it's organic, yes, as predicted here. You can try handling organic, different management method. You can try the videos. Okay, similar to the other one, the original one that we had seen. So this one. Yeah. So now we have a different kind of video, which is lab waste. Yeah. So some of these labs use organic waste. Yeah. Then you can try another video. Okay, now this is very relevant to this specific type of waste. So Canadians get creative in solving food waste problems. Yeah, so as you can see, it's actually doing very well in terms of generating the links and also giving recommendation. Use warm bins for efficient composting. Now this is the text generation bit. Then this is the recommender. So all of that was scaffolded using Python. Yeah, for the training of the models, both models, and also for implementing the recommender. Yeah, now we can try. Sometimes it tends to misclassify, which is one of the things that you want to work on. So you can upload this plastic and see what it's going to classify it as. Okay, that is accurate. Okay, let's try another one. Paper waste, yeah. No, it has classified paper as organic, which is inaccurate. So going to the specific technical side and parameters of things, we used a VGG16 model for the image classifier, which is a type of convolution neural network and for deep learning. Yeah, with an accuracy of about 48%, which is relatively low, and we plan to improve it. It was trained on an image data set of 7,200 images, and for each class we had 960 images. Then we used 120 sets of image for testing and validation, which was done for 8 epochs. Then for the text generation model, we used a T5 small model, and we used 240 rows, which is very little, excuse me. Then we use 0.1 for testing and 0.1 for validation, and the rest for training with 200 epochs. Yeah. So for the metrics of this, it gave very low perplexity, which is measure of uncertainty, and the rogue metrics were a bit high. Yeah. Then deployment. Classifier is deployed locally, where the text generation model is deployed on Hugging Face. Yeah. Then for the closing remarks, so future works, we plan on implementing locations. We had promised to implement this, but due to the current widened scope, we were not able to do so. Then with a few minor improvements on the model's accuracies, both models. Yeah. And the last one is going to be implementing rewards, which is going to be your go-to-market strategy. So rewards, incentives for waste management, things like carbon credits, money and vouchers. So we're going to partner with the local county government, starting small, or with the organizations like NEMA in Kenya. Yeah, then after we do that, we can make recycling, reducing, reusing, and handling waste fun. Thank you for giving us this opportunity we hope that you consider EnviroKen. Thank you so much.